Okay, thanks everyone for being here for lunch on Wednesday. So this will be kind of a fluid presentation. I didn't put in a lot of information. I'll talk about some software, show you some things, and so you should feel free to kind of ask questions as we go through. So let me just share this. Yeah, and also I'm going to be kind of popping in and out of the presentation with like the actual software, so it might be a little clunky as we go through. So basically, the idea today is just to introduce you to some of the software that's available for us as Rutgers Extension faculty that we have for free, and to give you some sense of how easy or difficult it is to use that software. As I mentioned in the abstract, there's kind of a trade-off with that, right? So it's like the harder the software is to use, the more flexibility and I might say power it has. I guess flexibility is a better word. But of course, for most things you want to do them easily and simply. So I won't talk about Excel. I think it's kind of wrong-headed to try to use Excel for statistics other than like, calculating the average or something. Because there's so many options that really are easier, and they're not necessarily that difficult to use. Like there's not that much of a learning curve where there'd be a hindrance to using them. Okay, so I'm going to talk about R a little bit. There's my buddy Grumpy Cat. So as I mentioned, or at least was what was in the abstract, what we'll talk about, I'll talk a little bit about R, and then SAS is a commercial program I'll talk about that we do have access to. And then I'll talk about Jamovi, which is actually an implementation of R, like a graphic user interface for R. So what is R? R was developed some decades ago. There was a program called S, which was something that was developed as a commercial software. Some professors got together and decided they were going to make something, and they decided to call it R because the internet wasn't really, like Google searching wasn't really common at that point. So they thought you could search for R and find it, I guess. And we would never do that today. But R is free. It's open source software. It's got a lot of power. It's well respected. It rivals anything else on the market. It's increasingly used in education and research. So I think I mentioned this later in the presentation, but like a lot of professors really like it because it doesn't give you a bunch of output automatically. It makes you ask for the output you want to have. So it's sort of like for students, it kind of forces them to know what they're trying to do instead of just giving them a whole bunch of stuff that they think they know what it means if they don't know what it means. There's lots of books and online courses and websites and discussion forums that have a lot of information on how to do things in R. But that being said, it's still difficult to use unless you have good examples. Oh, yeah, that's kind of funny. R is a computer language written by statisticians is like not a kind joke, right? It's a difficult language to use. Even if you've used SAS or SPSS in with coding, it's really a little more complicated than that. Like for all their shortcomings, SAS and SPSS did a pretty good job at making their coding a way that people could figure out how to run things. Kind of as I was getting at before, in our common analyses require several steps. So again, it's not like SAS where you say something, you say like do this procedure, and it kind of spits out everything you need. You have to kind of ask for everything along the way. So as I mentioned, it's good, you know, from like a professor's perspective, that students have to kind of understand what they're asking for, but it can be tough on new users to get this information. All right. So probably your question is, why not just make R easier to use? And people have. So I'm actually going to open up this link. Oops, that's not going to work. Okay. So we'll start with the first clunkiness. I'm going to copy this link, and I'm going to open it.
Hey, Sal, could you also put it in the chat, please?
Sure. So Amy, right now, can you see my screen, or do I have to share?
I'm still seeing your PowerPoint.
Okay, so I have to share that. And let me just put that in the chat real quick.
Thank you.
Sorry, as I said, it's going to be a little clunky just switching between all the different software.
You're doing great.
And yeah, now I'm not about to because I can't find the chat.
All right, I can try. Hold on.
No, it's just Zoom. Just need to okay, okay, I got it. It's just things change when you share your screen, so it's hard to find stuff, but okay. Anyway, this is just, you know, nothing authoritative, just an article on different GUIs for R. So GUI is a graphical user interface. So of course people have thought like, yeah, let's just make this easy to use. And here are some. So like Blue Sky is actually like a freemium model. You can see it's got, so the, what's the x-axis here? Number of features. So they're trying to, you know, kind of quantify how many features it has. Blue Sky is freemium. So they give you, you know, a free version and hope you'll buy the paid version. I think the rest of these are actually all free. So you can see they picked out some of the more common ones. One's called R Commander, Jamovi I'll talk about, Deducer's another one. JASP is another one that I like. So the point being that people have like tried to make good user interfaces for R. And again, there's kind of that trade-off, which is if you're using one of these things, it's point and click, it's nice to use, but it's not going to have everything. It's not going to have every feature that you may want. Sorry, it's going to take me a second to get back to somewhere I can share my presentation. Nope. Okay, here we go. So as I mentioned, like most of them are free. There's at least one that has a freemium model. There's probably a whole bunch out there that I don't know about or that weren't covered in that article. Jamovi is one of them. It's one of the ones I like kind of the most. It's got I like the way they do the statistics in there. Sort of how I see some things, and it's got some really nice output and graphics. Like it kind of spits things out in like a nice table format that you can copy and paste. It's got nice graphics you can copy and paste. And another thing that's really nice is that they have different modules. So they don't have a tremendous number of them, but there's a fair number of them. And you know, so they have some other like there's some other features that you can get to with them. So let's again, let me try to jump onto that one. Oh boy. I'm working on it. Sorry, everyone. It's like very, I can't. There we go. Okay. So here's Jamovi. It's free. You download it. It's got this, you know, menu up top. In this case, I'm going to open some data. Okay. So I have a data example. I'm calling it my Bob's Burgers example because I made up some things about burgers.
Can you share your screen, please?
Mm-hmm. Boy. Sorry about that. I'm working on it. That one, where's it? There it is. Okay. Okay. So I just opened up Jamovi on my computer. It's downloaded. I opened up a data file that was just a comma delimited file that has this data. Some of this data is real, but we'll just say it's made up about Bob's Burgers. I didn't come up with a great story about the burgers, but you can see we have some. It's basically set up as, if you're familiar with the design, it's set up as like a complete block design. So there's treatments. That's kind of what we're interested in. 1, 2, 3 treatments, but there's reps, and those reps are actually blocks. If that makes sense. If it doesn't, not important. So let's start by let's analyze weight. So we're going to look at the weight of the burgers. So I go to analyses. I think this will work. Right, so we'll put in the weight as the dependent variable, and we'll put in the treatment as the factor. And so you can see it does out the ANOVA table right here. So I think it's pretty easy to copy and paste that table out.
Hey, Sal?
Yeah.
So those symbols next to the names, like the ruler and then the three bowls, they mean something, right? Like I've gotten into trouble with Jamovi by not having them labeled appropriately.
The symbols. Oh, yes, yes, yes. Yeah, that's a really important point. It's an important point for all these softwares, right? So I don't know if I can bring this up. So basically with the way it's going to handle data and the way any of these programs are going to handle data is that there will be measurement variables or continuous variables, things that are measured that might have like decimal places. So something like height or weight, you could measure to some degree. You know, I could be 150 pounds or 150 pounds 0.01 or 150 pounds 0.02. And then some of them will be categorical variables. And just to be a little more confusing, a categorical variable could be nominal in scale. So like colors, blue, red, green, I think for most of us think of those as just, they can't be ordered in any way. Or if you have like a Buick, a Chevy, a Tesla, like there's no order to those. They're just categories. They're nominal categories. But other things could be ordered. You know, not hungry, hungry, very hungry. Even though those are like categories, they can still be ordered. So yeah, for any of these programs, it's important to know that they need to know this, the way, the scale, I guess is what we usually say, the scale of these variables, right? So in this case, there's a little ruler thing indicating that weight is like a measured variable. If I go back to data, you can see that weight, you know, it's got decimal places. So the software is sort of smart enough to know that those are like measured things. And then for like treatment, even though those are numbers, it was smart enough to treat them as a category. So you know, it's assuming that, I mean, 1, 2, and 3 are just categories. There's no order to them. All right. So yeah, that was a really good point, Michelle, because like that's one of the biggest problems people have in analyzing things, like, is because the software is assuming something about that data, and if you don't know what it's assuming, it turns out different. So I guess to redo this, but it gives you like lots of options here that I like. Again, this is Jamovi, so you can have your partial eta squared, which is an effect size measurement. If you know what that is, you can have eta squared. You can have an overall model test. Oh, it's not doing anything because I don't have these. Let's pick a different one. Let's do the umami measurement by treatment. Right, so it's giving you all this stuff. You know, if you know what this means, it's giving you the analysis of variance table, the p-values, the partial eta squared, the eta squared. Let me just click through a few things. For the assumption test, for example, you could look at the quantile plot. Again, that, you know, that's an assumption of the analysis of variance. If you know what that means, like that's pretty good. It kind of fits along the line. We don't need that one. Let's do this one. Does that come up here? down here. Yeah, and so here they have the post-hoc tests, which will compare, between the individual treatments. So it's comparing between treatment 1 and 2, between treatment 1 and 3, between treatment 2 and 3. So that's often something we want to know about. And then, as I mentioned, Jamovi has, there's obviously like a lot of different things we could do up here. Plotting things. But let's see what kind of plot. So this JJ stats plot is actually a module. Actually, I should probably show you that real quick. Let's see if this works. Okay, so you click over here, modules. You've got all these different modules. These are just different things people built, right? So you go through and pick the one you want. But in our case, I just downloaded this JJ stats plot, and let's do a dot chart. And again, we'll use umami and by treatment. And I don't see it. Oh, maybe it's trying. There it is. Oh, not what I was expecting. Okay, let's try a different plot. Let's try violin plot. Again, umami versus treatment. Okay, so you get these nice violin plots. They're a little hard to read, but they do actually have the median, the mean, give you some indication of the shape of the data. It actually gives you a bunch of statistics up here at the top. It looks like it runs like a Welch's one-way analysis of variance for you to see that. So, right, but the idea is like, it gives this stuff to you. You could copy this out, put it in your paper or whatever you're doing, and it looks pretty nice. Okay, so let me pause for a minute and see if there's any questions up until now, especially about like Jamovi, before I shut it down. If I can get back there.
So I don't see any questions yet. I don't
Okay.
know. Steve Komar does say, thank you for introducing me to Jamovi.
Okay.
But
Well,
now there's a question. Lauren says, to run Jamovi, do you also need the base R program, or do you just download Jamovi?
You just download Jamovi, so it's all kind of built in.
Okay, and then Steve wants to know, do you have to run each factor individually, each variable?
No. So we could do that. So you could do it as a sort of like a two-way analysis of variance. Like you would any other analysis of variance.
Okay. That's all I got right now.
Okay. So let me try to exit out of this. And share this again. Oops. No. Oops. Sorry. Okay, so let's get on to SAS. So some of us know about SAS. it's a very it's a expensive commercial software that's used in various fields. For those of us, I mean, I think it's really common in natural resources, agronomy, plant sciences, those kind of fields, environmental sciences. However, so we used to have access to it through Rutgers. When I first started, we did. It was kind of hard to use, but we did have that access, and then it went away. And then I found that we can use it through this thing called SAS On Demand for Academics. And I have to say, I don't entirely understand. So obviously the point here is that they're hoping, as if you're a professor or you're a student, you're going to use the software, and then eventually in the future, you're going to buy it and pay the, the subscription fee. And I'm not entirely sure like who this is open to. So using my NJAES Rutgers email, I was able to access this. I assume we all can. The idea is for non-commercial use. There's what I use is called the studio version, but there's something else called the enterprise edition. So I'm not going to comment on that. I don't know what all that means. And there are some resources there. So there's some like teaching resources, curriculum resources, online courses that we can access. So what I'm going to do is exit out of the show, and I'll copy this link.
Yeah, while you're doing that, Michelle put in the chat that there are some wonderful video instructions for Jamovi. So you can see lots of examples with simple data in the chat box that Michelle just posted. Thanks, Michelle.
Yeah, it's pretty good. I really like it. I've been pretty impressed. I have a few minor gripes, but it's kind of silly, They did a really nice job. And it's expanding, right? So none of these things are static. Like there's always people for the ones that are open source, there's always people contributing. But even of course for like SAS, they're always developing new things. Okay, so let me try to share. Oh my. Okay. I'll share this, so I just pasted in that link. And it brings me to the login page. So I have my login with my NJAES email, password. You have to click this box, you sign in. Go to SAS Studio. Right, and so basically you have all the, all the resources of SAS right here. So what I'm going to do is, I've got a little program I've already set up. Right, so this is what something looks like in SAS. It looks kind of bad, but if you start with a good example, it's not that bad. We put in the data, we have it reading the data, we tell it to run the model we want to run, and then if I just select this all and run it. Did something fail? Uh-oh. I thought it worked earlier. Yeah, so See, I told you it might be a real data analysis session where things don't work, but I just ran this right before the course. Ooh, what did I do wrong? Okay, so we'll debug real quickly. So it seems like it took the data. So I guess what you can see from SAS anyway is it's a very different environment, right? So it's giving you like, you know, the log of what it's doing, how long it took to run, you know, and then you get, yeah, we'll skip that. If you got results, you get results, but here you got the log of errors, which I guess I have some. I really thought I just ran this thing. Boy.
Is it because you have a semicolon in line 18?
No, that's supposed to be there. Thank you, though. That's. Oh, it might be missing from the end, actually. There we go. Yeah, so it was actually the exact opposite problem you mentioned, Melissa. I was supposed to have a semicolon that was not there. Right, so I guess that tells you something. Like I copied and pasted it. I must have not grabbed that last semicolon. It didn't work. You could sit there for a long time trying to figure out why the code that you already ran didn't work again. Right, so that's kind of the limitation of something like that. SAS is really powerful. It's really an industry standard in a lot of disciplines. Like I mentioned, in my upbringing in agronomy and natural resources, it's the one everyone uses. It's well respected. It's also, because it's commercial, it's got some of that commercial weight behind it, right? Like the thing with R, and we'll get to this in just a second, but like the thing with R is like people can write their own packages to do things in R, and they kind of go into the repository. So for example, I have my own package in R, and people can download it and use it. But do you trust me as a programmer or as a statistician to not make errors in that? You probably shouldn't, because chances are, obviously, if there's something wrong, then I fix it. But it's very easy for people to make errors in those things. And SAS kind of has that weight of being a big corporation where, because they're paying people to work on the software. Whereas a lot of the open source stuff, it's all voluntary. So there's a lot of like university professors working on the weekend, and errors can creep in there. But what's nice about SAS, so it gives us all these results, gives you some kind of basic information. It gives you that same analysis of variance table that we saw before, R² for the model. It automatically spits out some plots, which, like as I mentioned, like R doesn't do that. You have to ask for those all separately. Some more data, some more plots. Right. So the idea is it spits out a lot of stuff at you, which is probably all useful if you know what it means. But as I mentioned, one of the advantages of R for professors who are teaching a class is that they don't want their students to get a bunch of stuff that they don't understand. They want them to understand what they want and to get those things. Okay. But, starting with an example, I know this looks kind of awful, But if you had this example somewhere and you could copy it and put in your own data, pretty easy to run, gives you some nice looking results, gives you some plots, gives you some tables. You can export all this, by the way, too. SAS is pretty good about that. Okay, so let me move finally the straight up R Studio example. Okay, so I guess I have a slide on this, but it's not important to see. R Studio is just a it's an IDE. It's just a development interface of R. So R is kind of behind this in the background, and R Studio is just a way to make it easier to use. So you have different windows, so it makes it easy. So I will. Oops. Give me a second. Let me share that again. Okay. Here we go. So let's see if I can open. Okay, so here's the example in R. It doesn't look too much worse than the one in SAS, but as I mentioned, it's a little bit more difficult to find. I guess it's harder to find like good examples to use in R. Once you're used to it, it's great to use. I use it for lots of stuff, like even if I'm just like need to get an average of something or keep track of something. But you put in your data, you have all these commands where you're telling it what you want to do. You want to do this analysis of variance and what you want to get out. And I've got some plots as well there. So that's not too awful. You run that. So actually we'll skip the plots, and if we can look at this window, this is the output window. Right, so it kind of spits back everything we told it to do. Again, it's got this right here, this analysis of variance table, which will match up with the other analyses if we did them the same way. I think I did them differently in Jamovi, which was Steve's question. So like here, for example, Steve, it's got both the treatment and the rep, and we could have done that in Jamovi. Although actually also in Jamovi, we're using the umami as the dependent variable. This one's got, we can scroll back up. This is actually using the weight, just the example I used. And then we get some, so that's kind of the results we want. And you might notice like it's not a table that, I mean, you can copy and paste that easily as text, but you probably want to reformat that if you're using it for something. And then you got some plots. Again, they're not the, you can make good looking plots with R, but just kind of the default plots. I don't know if that's ours. This was that normal quantile plot that we had seen earlier, and some other model checking plots, right? So you can get those out in R. Again, by default, the plots they make, they're not that pretty. So if you want to use those, you'd have to make them. There's packages in R again where you can make pretty plots. All right, let me stop sharing. And I'll take any questions or any comments. Steve's in the chat mentioning you can also buy the SAS software. Which, yeah, if you're, I mean, if you're going to use SAS a lot, it's probably worth your while to buy it and have it on your computer. Using it online is not bad at all anymore. Like I mentioned when I first started here, it was available from Rutgers, but it was like pretty clunky. Any thoughts, questions, comments?
It's pretty quiet in the chat. Oh, now Steve Virgil has a question.
Okay, so Steve Yerjo asks, I need help figuring out which stats to run in the first place. There are some guides online that I can probably share with you. Really, sometimes it can be complicated, right? So, I mean, the first thing to figure out is what you want to know. I mean, we might say that more technically is like what hypothesis you want to test. But really, it's like in general, what are you actually trying to figure out? The second thing that's really important is for your dependent variable, for like whatever you're measuring, what kind of variable is it? Because if it's a count variable, if you're counting things, or if you're measuring something like height or weight, or if you're or if you have like a or like an ordinal scale, like your questions are, you know, 1 through 5, how do you feel about this thing? In general, like the tests you're going to use are very different. And sometimes, I mean, I mean, really, the honest advice for like a lot of these questions, I was mentioning kind of before the program that I am on some social media sites where people ask these questions, and oftentimes it's really like you have to sit down with somebody who is either a statistician or somebody in your department that's pretty good with it, and kind of figure out what you want to do with it. Hopefully that's helpful. I mean, I know it's but I guess I can share some of those guides for people.
Do you see the next question?
Yeah, and I'll follow up on what Steve said. Like, it's more of an art than a science. Not necessarily, but we have so many techniques at this point, especially with computers, that there can be a lot of different ways to approach something. Hopefully, in the end, it doesn't matter how you analyze it, right? Like if you're testing a drug that cures cancer, right? Probably, if you've done the experiment right, how you analyze it probably doesn't matter that much, because you should see like there's an effect there. But there's a lot of different ways, especially with computers, that we have to, sometimes just use the power of the computer to just kind of use like a randomization scheme and just try different things and see. Well, that's a poor explanation, but yeah. So hopefully your technique doesn't matter that much, but sometimes it can. But if there's a really clear effect, then you should be able to see it. I mean, there was, someone once said, if there's an effect there, you're going to see it when you look at the numbers or plot it out, and you don't really need statistics for it. And to some extent, that's true, except that we make more complicated models. But if it's something there that's obvious, you should be able to see it. Sort of, no matter what you do. Yeah, so Steve has a question specifically about like SAS programming. Yeah, and Steve, you're absolutely right. Like the sort of the best and easiest way to approach things like R or like SAS is to have an example that's pretty much exactly what you want to do, and you type it in or copy it, and then just put in your data, and it works perfectly. That's sort of the best way to start. And that's the way we teach a lot of courses, I mean, we'll say, okay, this is a randomized complete block design, and here's your SAS code. And then, in the future, that student will change that data when they have a randomized complete block design. So if your question was it started off with would you be willing? So yeah, in general, I can try to help people. I'm not the best at everything, and there may be a cost in terms of including me on a publication or something. But in general, yes, I'm willing to help people try to suss some of this stuff out.
Okay, well, are there any other questions or comments? Thank you, Sal, for this little walkthrough, and thank you everyone for joining us today. This is recorded, so if you need to refer to it, I'm sure it will be posted on our department YouTube channel. So thanks for joining our Lunch and Learn, and we will be having more educational webinars. I think our next one is about the soil web survey. I think it's April 22nd, but we'll be sending an announcement out. So maybe we'll see you guys there.
Thank you very much, Amy.
Yeah, thanks, Sal.